Good day, everyone. Let me present to you some examples of compound interest. From problem number 1, at what percent per annum will $3,000 amounts to $3,998 in 5 years if the interest is compounded annually? Problem, we're looking for the rate percentage. The principal amount is equal to $3,000, then the amount accumulated is $3,998 within 5 years. As we observed, the easiest way to find out the value of rate percentage is to use the formula for rule number 1. This is the formula of rule number 1. Then we will now substitute the values to the formula. We can now solve the value of the rate percentage. The result is 5.91% as the rate of percentage. For example number 2, the compound interest on 15,000 in 5 years at 5% per annum. The interest being compounded half yearly is, so we're looking for the interest of 15,000. The principal amount is worth 15,000 with a rate of 5% and a time frame of 5 years. So we will use the formula to find out the value of interest, which is the difference between the amount accumulated and the principal amount. But before we can proceed to this, we will compute first the value of the amount accumulated. We can directly use the rule number 1 formula to find out the value of the amount accumulated. We will now substitute the given values and the result is equal to 19,144 and 22 centavos. Then we can now substitute the values to the interest formula and the result is equal to 4,144 and 22 centavos. For example number 3, a sum of money on compound interest amounts to 10,000 in 3 years and 9,000 in 2 years. The rate of interest per annum is, so in this problem, we're looking for the value of the rate of interest considering the two amounts accumulated, and these are 10,000 for 3 years and 9,000 for 2 years. We cannot directly use the formula to solve for the value of rate percentage because of the given values. We will first use the formula of rule number 1 and substitute the given values. So we have now two equations with two unknowns, and these are principal amount denoted as P and the rate percentage denoted as R. To proceed to the next method, we use the elimination method. We will eliminate the principal amount from the equation to solve for the value of the rate that we were looking for. This is now the equation. We can now directly solve for the value of R. Then the result is equal to 11.11%. For problem number 4, the compound interest on 3,000 in 3 years if the rate of interest is 4% per annum for the first year and 3% per annum for the second year, and 75% of the first year rate will be. So in this problem, we have a principal amount of 3,000 within the time frame of 3 years, but we have 3 different rates consisting of 4%, 3%, and 75% of 4%. So we're looking for the compound interest, which has a formula for the difference between the amount accumulated and the principal amount. We will first solve for the value of the amount accumulated by using the formula of rule number 3. Then we will substitute the values to the formula, and the answer is equal to 3,310. We can now directly solve for the value of compound interest by substituting the amount accumulated and the principal amount. Therefore, the result is equal to 310 as the amount of compound interest. For problem number 5, in what time will 9,000 amount to 12,000 at 30% per annum compounded half yearly? So in this problem, we're looking for the value of the time frame. The rate of percentage is equal to 15% every half year. Then we can directly use the formula of rule number 1 in terms of the amount accumulated. Now substitute the given values to the formula, and the result of the time frame is equal to 2 half years. So it means it is equal to 1 year only. For problem number 6, a certain sum of money yields 1,200 as compound interest for 4 years at 6% per annum. Now the sum is, so in this problem, we're looking for the principal amount. Let us know what are the given values for the sample problem. Compound interest is equal to 1,200. The rate of percentage is 6%, and the time frame is 4 years. Now the easiest way to solve for the value of the principal amount is to use the formula of rule number 1. Then we can now directly substitute the values to the formula, and the result is equal to 4,571 and 83 centavos. Let us proceed to example number 7. A man borrows 20,000 at 8% compound interest. Now, how much does he has to pay annually at the end of each year to settle his loan in 2 years? And the next question is, how about in 3 years at 6% compound interest? So in this problem, we're looking for the principal amount that he has to pay annually. Let us know the given values that correspond to the first question. The compound interest is equal to 20,000 at a rate of 8%. To solve this, we will use the formula of rule number 11, as several years is equal to 2 years. We can now directly substitute the given values to the formula. Therefore, the value of the principal amount is equal to 39,952 and 05 centavos. Now for the second question, under sample problem number 7, the time frame is 3 years and the rate of percentage is 6%, but the compound interest is still equal to 20,000. We will use the same approach from the previous, but we will add another function that corresponds to 3 years. Then we can now directly substitute the values to the formula, and the result is equal to 59,928 and 7 centavos. How about sample problem number 8? The compound interest on a sum of 5,000 at 12% per annum for 9 months when interest is compound quarterly. Now in this problem, we're looking for the compound interest as the principal amount is equal to 5,000. When it comes to the rate of percentage, the 12% annually will be converted into a per quarter rate, and the time frame of 9 months will also be converted into quarters. So the 12% became 3% while the 9 months became 3 quarters. It is important to change the unit to get easily the answer in terms of what is stated as required in the problem. We can now use the formula of rule number 1 and directly substitute the values to the formula. So the answer is equal to 463 and 64 centavos as the compound interest of 5,000. For sample problem number 9, the compound interest on a certain sum of money at a certain rate for 3 years is 60.8, and the simple interest on the same sum is 50 at the same rate and for the same time. Now the rate of interest is, so in this problem we have two formulas involved. These are in terms of compound interest and simple interest. So these will be the formulas that we will be going to use. Then we will substitute all the given values that correspond to the formula. As we observe, we created two equations with two unknowns. All we have to do is to eliminate one of the unknowns, so we easily solve the value of the other. We will remain the rate unknown as it is what we are looking for in the sample problem. Then we can now directly solve for the value of rate percentage, and that is equal to 43.2%. For the sample problem number 10, the simple interest and compound interest compounded annually on a certain sum of money with a given rate of 3 years are 800 and 894 respectively. Now the sum of money is, in this problem, we will solve first the rate and the last one is the principal amount related to the compound interest and simple interest. So we will use the formula of rule number 10 as the easiest way to determine the values that we're looking for. We can now directly substitute the values to the formula as compound interest is equal to 894 and simple interest is equal to 800. Therefore, the value of the rate of percentage is equal to 23.5%. So we will proceed to the simple interest formula as we are looking for the value of the principal amount. Then we will substitute the values to the formula, but the rate that we will be going to use is equal to 23.5% and the time frame is 3 years. So the answer is equal to 1,134.75 as the principal amount of money. So these are some of the examples of compound interest. From these sample problems, we observe that it is not easy to directly use the formula of 11 rules, but we need to understand what is stated in the problem because sometimes we need to create another formula for us to proceed to the stated formula in the rules of compound interest. So that's all for today and keep safe everyone.